This video continues our discussion of the idea of having a distributed file system for storing your big data and then aggregating that data. So if you have data distributed across different nodes in a system, then there ought to be a good way of handling the queries and using the processing power of each individual node so that um, you can reduce the load on the end of it. So one of the things that came out of this idea was the MapReduce programming paradigm. Google originally came up with this idea in 2004, and it's taking advantage of that parallelism that exists when you have data that's distributed across multiple systems. So what this allows you to do is offload some of the work onto the individual servers so that, especially in a big data system, it's not nearly as taxing on a singular server. So the data um, in HDFS in Hadoop or the data in a Google file system is broken up into blocks or chunks. So the idea is to first filter that data and transform it inside each node or each block and do this step in parallel. So this is called the map step. And so that's all you're doing is filtering on each individual node level and doing the map there. The next step is to do a shuffle. It's not listed here, but I'll show you this pictorially in a minute. The shuffle step takes the mappings and then moves them into a place where you can then do a reduction. So the reduce step takes the mapped data that was performed. The shuffle gets all of the pertinent data together, and then the reduce step actually performs the calculations or the aggregations on that data. So then it produces the output. So this diagram kind of depicts that. You have a data set that is distributed in Hadoop distributed file system across several blocks. So those blocks are then used to do an initial query. That initial query is the mapping that takes place. You're mapping out the keys and the values that you want to actually operate on. The shuffle step then takes that data and moves it to the location where you'll be doing the reduce step. The reduce step then aggregates that data that you have, and then finally you produce output from that situation. So here's a concrete example of this. On the left, you see a list of orders. You have customer ID, amount, and status. On the right side, we notice that we want the goal of adding up all of the values for a particular ID. So our query first is that we're mapping A123 and B212. So we're querying that. Notice that A123 is listed at the top with amount 500. A250 is listed. So this is everything that is where the status is A. So these are all the active statuses. All right, so the next step is, so that's the query. That's what starts all this together. Then you're actually taking the information that you want from each of these documents and then mapping it. So you're mapping it, and this also includes the shuffle step. And I'll show you another example that shows this a little more clearly. But the map plus the shuffle step leads to this central item right here where you have a list of items. So now we have the 500 amount and the 250 amount for A123 and the 200 amount for B212. The reduction is actually to do the aggregation. So now we're just summing that together and we're producing an output document that has the value of 750, which is the sum here, and has a value of 200, which is the sum here. So here's a more concrete example of using Hadoop for MapReduce. On the left side we have a data file, and that data file contains several instances of dog names. So we just want to count the number of dog names so we can find which is the most, which dog name is the most common. So of course we could just look through this and count, but this shows us how we can use Hadoop or Hadoop distributed file system to do this. So if you remember in HDFS, it breaks the file into blocks. So let's assume that when that file is stored in HDFS, then it's stored into 3 separate blocks. So the first block, it gets a key value pair. Block 1 has record 0, record 1, and record 2. So that's Bob, Fido, Bob, Max, and Sue, Indy. Block 2 then has 3, 4, and 5, which is Joe, Mushu, Karen, Blue, and Karen, Max. And then block 3 has 6, 7, 8, Jill, Ruby, Jill, Max, and Andy, Fido. So the next part of this is mapping. So this is the raw form of the data itself, and we want to map that data into a format that will allow us to count the number of dog names. So on this particular block, we know that there's a Fido, and that's one instance of a Fido. We know there's a Max, there's one instance of a Max, and an Indy there as well. So now we complete this process on each block. So this happens in parallel, which greatly speeds up the processing power that we have. So now we have the mapping from the dog name to the count of that dog name on each block. So the next step is we have this output in the block, and now we have to shuffle it. So the shuffling looks like this. So the shuffling takes the dog names and it puts them together. So Fido now has a list of 1, 1. Max has a list of 1, 1, 1. This is the counts that we had from each block. Okay? So another way that you could do this is you could list each output from the map step here as well. So you could say 1 for blue or 0, 1, 0. Because there was no blue here and there was no blue here. So in that way you also know which block it came from. So now we're ready to perform the reduce step, and the reduce step is taking what we have just shuffled and then mapping that to some output. So here's the output. We have a total of 1 for blue, 2 for Fido, 1 for Indy, 3 for Max, and so forth. So this is the actual output of our MapReduce process. And finally, here's another picture of what we just did. Notice that here's our input block and our output of the map step. Our input block, our output of the map step, input block, output of the map step. The shuffle step shows you that we're taking these values and moving them to a particular place, and then we're ready to do the output from the reduce step. So the input to the reduce step is this list of values, the list of counts that we have, and the output is the actual count itself. So in a nutshell, that's MapReduce.